ISO 20022, ISO 8583, India's UPI, Mexico's SPEI, and other international or local financial messaging standards didn't break payments. It exposed what was already broken. Many banks assumed the hardest part would be converting legacy payment messages to the international standard like ISO 20022. But if that were true, we wouldn't still be losing over $100 billion every year to failed payments. In this video, we'll show why modernization isn't about formats at all and why a canonical JSON model combined with agentic AI is becoming the real foundation of modern payments.
Payment standards didn't introduce complexity, they revealed it. Increased payment complexities didn't come from richer messages alone. They failed because our systems were never designed to understand payments end-to-end. Every payment still travels through a maze of systems, from core banking, payment engines, fraud, compliance, reconciliation, to customer channels, each with its own data model, its own interpretation, and its own logic. So, when ISO 20022 arrived with more context, those systems didn't become smarter, they just became more inconsistent.
This is a real issue. Most modern payment failures aren't caused by bad messages. They're caused by systems that don't share a common language. The same payment means something different in every place it touches. So when something goes wrong, no system has the full picture, no team owns the truth, and resolution becomes manual, slow, and expensive. ISO 20022 exposed the gaps in the system, making them impossible to ignore.
This is where the idea of a canonical payment model comes in. Instead of letting every system define payments differently, you define one shared technology-agnostic representation, a canonical JSON model, which represents the payment once, preserves full business context, and stays consistent across the entire lifecycle. Messages of ISO 20022 and other payment standards don't disappear. They simply map into and out of this model to support a world of evolving multiple payment rails. The canonical model becomes the source of truth. Everything else becomes an adapter.
A canonical model is what makes payment data easier to centralize and unify. JSON is the format that makes that model practical at scale. With a canonical JSON model, payment data from multiple rails can be represented once in a single structure. Systems stop maintaining parallel models in silos. Data becomes unified and queryable in real time, and context is preserved across the entire payment lifecycle. And most importantly, it creates the foundation for the next shift in payments architecture.
This is where agentic AI becomes practical, not theoretical. AI agents don't work well with fragmented, inconsistent data, but they thrive on clean, contextual, unified models. With a canonical payment model, agents can detect issues across systems, understand why a payment is delayed or failing, and assist operation teams with faster, more accurate resolution. Automation on top of messy systems only perpetuates chaos. True intelligence comes from a shared understanding.
This approach needs a platform that can handle rich, evolving payment data, high-volume transactional data, and real-time access and analysis. MongoDB fits here naturally. Its document model maps directly to canonical JSON to support multiple payment rails and agents use. In a world where JSON is the common language for APIs and AI, that means the same payment document can drive your system of records, engagement, and agentic actions. Its flexibility supports continuous change, and its scalability supports real payment volumes with speed and resilience on-premise, on cloud, or in a hybrid deployment. MongoDB enables canonical data and agentic AI to move from theory into production. We've talked about why a canonical model, agentic AI, and how MongoDB can enable the realization of the data, the foundation for modern payments. Now, let's see it in action. Kieran will walk you through a live demo on MongoDB.
You have seen the concept. Now let's look at the architecture that makes it real. At the center of this platform is MongoDB Atlas. It serves as a unified operational data layer. On the left, we have the message translation service. It takes any input, whether it's legacy Swift, ISO 853, or ISO 20022, and normalizes it into a canonical JSON model. This flexible structure allows us to integrate diverse rails from local real-time payments to global stablecoins into a single system without maintaining separate silos for every format. But the real power lies here on the right, the Agentic resolution service. When the data is incomplete or invalid, you don't just log an error. A supervisor agent wakes up, analyzes the problem, and routes it to specialized agents. equipped with tools like Atlas search and vector search to fix the payment autonomously. Let's see this live. A payment leaves Germany, headed for Japan. The beneficiary name is Dentsu Corporation, typed in English. But Japan's Genjin clearing system won't accept Latin characters. It needs katakana. In a traditional setup, this payment stops cold. It sits in an exception queue. Someone investigates days later, and settlement slips. Let's see what happens. I'll hit simulate. The platform ingests the message, converts it to a canonical JSON, and detects the validation error. Beneficiary name requires conversion. But instead of failing, the supervisor agent activates. It analyzes the context, identifying a script mismatch, and routes it to a resolution agent. Here's the logs on the right. The agent isn't guessing. It first checks our internal database using Atlas search to see if we already know this beneficiary. If not, it calls an LLM tool to perform the transliteration from Denso Corporation to Katakana. It's treating the error as a task to be solved, not a reason to stop. Now, this is critical for financial compliance. We cannot simply let AI override payment instructions without oversight. This is the human in the loop workflow. The agent pauses execution and presents its solution to me. I can see the original value, the proposed katakana translation, and the agent's reasoning. I'll approve the fix. The validation passes and the payment proceeds to settlement. But the real magic is what happened to the data. Now let's look at the backend. This is a canonical JSON stored in MongoDB. Translation service converted the legacy Swift message into this flexible document structure. This allows the agent to enrich the data, like adding those katakana characters, without breaking a rigid schema. But the real power is this configuration document. The rules for translating that input and formatting the finalized 2422 output are not hard-coded in Python. They are stored here as data. If a regulation adds a new field requirement or you want to support a new message format, you update the config, not the code base, making this architecture intelligent, document-driven, and completely adaptable.
ISO 20022 wasn't the destination. It was the moment the industry realized that format changes don't equal understanding. Real modernization starts where payments are canonical, contextual, and intelligent by design. That's when automation becomes trustworthy. That's when payments finally become fast, reliable, and without friction. If you want to explore this architecture in more detail, from canonical models to agentic workflows, check out the blog and demo in the description.